This is a presentation on Shanon-Fano coding in two different methods, and we are going to see like which is the best method and following which procedure. So first consider the given probabilities. There are 7 probability values given. So as per the procedure, the first step is arrange the probabilities in the decreasing order. It has been arranged. And the first step is we have to segregate the available probability values into equal half or almost equal half. So in this case, if we see exact division of probabilities is not possible. So now the first division is 0.4, and when all these values are added, it is 0.6. So here the first segregation is done, and to one subdivision a 0 value has been assigned, and to the remaining probability values a 1 has been assigned. So the first column is over. So divide the probabilities into almost equal halves. To one half assign 0 and to the remaining half assign 1s. And in this first subdivision only one message is given, so this is done. So the code assigned to 0.4 is just 0. And the next subdivision, if we take it, is 0.6. Once again, this has to be segregated as 0.3 and 0.3. Even that is not possible. So it has been divided into 0.32 and 0.28. So here is the next segregation. So this subdivision and this has been separated. To this subdivision, 0 value has been assigned, and to the next subdivision, a 1 has been assigned. So the second column also has been done. Now when we refer to this particular subdivision, it has got 2 messages. So once again, this has to be divided into 2 equal halves or almost equal halves. So this has been divided, and to one division 0 has been assigned, and to the other division 1 has been assigned. So the remaining, we have some 4 messages. Once again, following the same category, equal or almost equal half subdivision. So the first 2 has been taken as one subdivision. So the next 2, which belongs to almost equal half category, this division is done like this. And to this half it is a 0 value, and to the next half there is a 1 value given. And once again, when we refer, there are 2 messages in this subdivision. So it has been divided as a 0 and a 1 message. Similarly, there is another 2 ones, 2 messages present. So to one message we are assigning 0, and to the other message we are assigning 1. So the coding procedure is almost done. With 0.4 has been assigned as 1, 0.2 is 100, similarly 0.12 is 101. Now let this NK indicates the number of bits present in every code word. So for this, if we are going to calculate the efficiency, the L bar value is the average length. So this is a formula, and we need to multiply the probability and the respective number of bits present in the code word, and we need to sum it up. So it goes like this: 0.4 into 1 plus 0.2 into 3, etc. It goes 0.04 into 4 as per this formula. The answer got is 2.48. Now for this, the entropy is calculated. So summation minus summation pk log pk, it is log to the base 2. When we substitute, the answer is found to be 2.4205. Okay, now this is a binary encoding scheme. So m value is equal to 2, and the efficiency formula is h of x by L bar log m to the base 2. H of x value is 2.42, L bar value is 2.48. So as per this, the efficiency is calculated to be 97.6%. This is by following one method where we have segregated 0.4 and 0.6. Now the next method, in this the first subdivision is 0.6 and the next subdivision is 0.4. If we are going to segregate at this point, we are going to see what efficiency we are going to obtain. So it starts with 0.4 as the first group, 0.6 as the first group, and 0.4 as the second group. To the first group we have assigned 0s, and to the second group we have assigned 1s. Now concentrating on this subdivision, there are 2 messages. So one message is assigned a 0 value, and the other message is assigned a 1 value. Now concentrating on the lowermost messages, so this addition of these 2 gives me 0.2, and when we add all these 3 probabilities, it is once again 0.2. So it is exactly equal half. So exactly equal half subdivision, with one group assigned a 0 value and the other group assigned 1 value. Now to this subdivision, once again it has only 2 messages. So to one message it is a 0, to the other message we have written a 1. Now coming to the next 3 messages, so here 3 ones are present, 3 messages. So here the segregation has been done like this: 0.08 and 0.12. No other go. If we go for 0.16 and 0.04, the difference between the grouping is really high. So we have to prefer 0.08 and 0.12. So the division has been done over here, and to this division you have assigned a 0, to the next portion it is 1. It is ones. This is a single message, so the coding is done for this 0.08, which is 110. Now concentrating on the remaining two messages, following the same procedure, to one message it is 0 and to the other message it is 1. So the coding procedure is over, and we have written the number of bits present in every code word. For this, using the same L-bar formula, if you're going to calculate, the answer is 2.52, and anyway entropy doesn't change, which is 2.4205. Using the efficiency formula, if we calculate, it is 9.05. So when we compare these two methods for the same Shanon-Fano coding procedure, the efficiency obtained by method 1 is higher when compared to the efficiency obtained by method 2 for a very simple reason. The highest probability message should be assigned with the shortest code word. Here the 0.4, the code present is only 1 bit, whereas for this 0.4 the code obtained is 2. So when this is a situation, the L-bar value, there will be a difference in L-bar value, which is the average length. So there the L-bar value is obtained to be 2.48, and here the L-bar value is got to be 2.52. Since the L-bar value is a higher value, obviously the efficiency becomes a lesser value. So the net inference from this presentation is, when we are segregating probabilities into equal halves, if we are not able to segregate them into equal halves, we have to go on for almost equal category, in which case the highest probability message should have the shortest code word. In such a way, if we are going to do the coding procedure, net the result will be ending up with the highest efficiency. This is what I wanted to convey in this presentation. The final inference is, in Shanon-Fano coding procedure or in any other coding procedure, like say another coding procedure is Huffman coding, the highest probability message should be assigned with the shortest code word. Because of that, the average length average length increases. Because of that, your efficiency reduces. If the average length is a reduced value, your efficiency increases. Hope this video will be really helpful for the students when facing such a kind of problem. Thank you.